Hello, am I audible? Hello.
Yes, it is audible.
Yes, am I audible?
Yes,
Okay. Okay. So, hello everyone. I'm Pankaj Kapli. I'm NPTEL PMRFTA for the course of Engineering Mathematics 1, and I'll be taking live sessions of this course. So, this is the week 7, and I'll be discussing some problems related to the lecture videos of this week. So, mostly the problem will consist of computation and applications of double and triple integrals. Okay. So let's start with the first problem. Okay, so here we have to find the area outside of a circle, which is x square plus y square equal to 1, and inside the another circle, which is x square plus y square equal to 9. Okay, so what we will do? So let's draw the region first, whose area we have to find. Okay, so let's say this is our 3. So there are two circles. Let's say one circle of radius 1 and then another circle of radius 3, and we have to find the area in the second quadrant. So basically we have to find this area. Okay, so we just note that this area of the shaded region will actually be equal to this particular area also. It doesn't matter in which quadrant you find this area. Okay, so to find this area we'll use this double integral. So let's say this is our domain D. Okay, so our area will be equal to a double integral of this dx dy over the region D. Okay, now sometimes easier to change the integral into some other coordinates. So instead of this rectangular coordinates, we will be using polar coordinates. So in polar coordinates, we put r is sine theta and x is r cos theta, where x square plus y square is r square. Okay, so this dx dy will take value r dr d theta. Okay, so this integral will just become r dr d theta, and now we have to find the limits of this integral. Okay, so note that if you just fix an angle theta, let's say theta equal to constant, the value of r varies between 1 and 3, right? From this point to up to this point. Okay, so that is r varies from 1 to 3, and this theta varies from 0 to pi by 2. Okay, so these values we put in the integral. So r from 1 to 3 and theta from 0 to pi by 2. Okay, so now because these limits are just constant, we can just write this double integral as product of two integrals, one with respect to theta and another with respect to r. So this is just 0 to pi by 2 d theta into 1 to 3 r dr. Okay, and that is precisely pi by 2 into r square by 2, and putting limit from 1 to 3, right? So that, so how much it is? It is 3 square by 2, which is 9 by 2 minus half, which is 9 by 2 minus half, which is 4, right? So area will become 2 pi. Okay, so the option C is correct in this case. So are there any questions regarding this problem?
No, it is very simple problem. We want a ring-shaped area.
Yes.
Uh,
Okay.
Actually, I want triple integral. Suppose if I am only this listening, please explain triple integral with spherical coordinates or cylindrical polar coordinates.
Okay.
Rest of all are not needed.
Okay. So there are some problems related to the triple integral also, which will be doing mostly by changing the coordinates into spherical coordinates. But I don't think I have I have inserted some problem related to the triple integral where the coordinates are changed to cylindrical coordinates. Okay, let's okay, then let's start with the seventh problem then this is the one
Okay.
problem on triple integral.
Okay.
Okay, so we have to find this triple integral, and the volume V is bounded by this sphere, where it's the sphere of radius 3, right? So our volume is just this sphere. Mm, right, it's a sphere of radius 3. Okay, so we have to find this volume integral. Let's call so x square dx dy dz. Okay, now for now we'll change this integral to the spherical coordinate. So we'll put x is equal to r sine phi sine theta, y as r cos phi sine theta, and z as r cos theta, right? So are these coordinates correct?
Okay.
Okay, so that means x square plus y square plus z square is r square, and instead of this dx dy dz we can write r square sin theta dr d theta and d phi. Okay, so what we will do, we'll just okay, so first note that to if we are integrating this triple integral over the volume of the sphere, that means the r varies from just a sphere of radius 3, so r varies from 0 to 3. Now this theta varies from pi by 2 to minus pi by 2, and phi varies from 2 pi to 0. Okay, so what we'll do, we'll just calculate this compute this integral in the first octant, right? That means where x y z all are positive, so in that case you just write it 8 times, and we'll put limit from r 0 to 3 and theta from 0 to pi by 2 and pi from 0 to pi by 2. Okay, so we are, instead of x square, let's write r square sin square phi sin square theta, and we have r square sin theta. and then dr d theta d. So this 8 times what we can do is just calculate this integral from 0 to 3 respect to r4 dr, then another integral respect to 5, another integral respect to sine cube theta, again from 0 to 5 by 2. Okay. Okay, let's find these integral one by one. So integral of sine square d phi, sine square phi d phi 0 to 5 by 2, right? I think I have done some mistakes. This is r cos phi. So here this 2 got interchanged. So r cos phi and here r sin phi, and therefore instead of sin square here we'll have cos square phi. Okay, so let's use this double angle formula. So what is cos 2 phi? Is it 2 cos square phi minus 1, and this will just give us cos 2 phi plus 1 divided by 2 is equal to cos square phi. So instead of cos square phi, we'll write cos 2 phi plus 1 divided by 2, and we integrate this one. Okay, so half will come out, and this is phi plus sin 2 phi divided by 2, and you just take limit from 0 to pi by 2. Okay, so this will just give you pi by 4. Next, calculate this integral r cube. So this is 0 to 3 r cube dr. This is just r to the power 4 by 4 from 0 to 3. So this is 9 times 9 divided by 4. So 81 by 4, right? And now we have to calculate the third integral, which is sine cube theta. Again from 0 to pi by 3, pi by 2. Now we'll use this formulas of sine 3 theta. So what is sine 3 theta? It is 3 sine theta minus 4 sine cube theta. Now from here we'll just extract sine cube theta. So what will become sine? What is sine cube theta? And sine cube theta is 3 sine theta minus sine 3 theta divided by 4. Okay, so we'll take 1 by 4 outside, 0 to pi by 2, 3 sine theta minus 4 sine 3 theta. And so what is the integral of sine theta? It's minus cos theta, right? So we'll have cos theta divided by 3 minus 3 times cos theta, and we are taking limits from 0 to pi by 2. Okay, so cos pi by 2 is 0 and cos 3 pi by 2 is also 0. So just so only the lower limit will give this is 8 times pi by 4 into 81 by 4 into 2 by 3. Okay, so 4 will cancel this twice, and all these twice cancel with 4. Okay, so I made another mistake. So here note that this integral is r to the power 4. Integral of r to the power 4. So here this integral is r to the power 4. So this will come out to r to the power 5 by 5 from 0 to 3. So again we'll have 81 times 3 divided by 5. Okay, so let's write this integral again. So 8 times 5 by 2 into 2 by 3, and this is pi by 4. 81 times 3 divided by 5. So these 3 will cancel. 4 will cancel this 2 times. So 324 divided by 5 pi. So that's our answer. So 324 pi divided by 5. Okay, so answer B is correct in this case. So, okay, so are there any questions?
No. Please continue next problem.
Okay. So okay, so again a triple integral problem, where this problem is about also spherical integral. Spherical will change the integral into spherical coordinates. So it's e to the power x square plus y square plus z squared and root. Okay, so let's write e to the power under root x square plus y square plus z square over the volume V. So what is our volume? Again, the sphere of radius 1. Okay, now we just change this integral to the spherical form, into spherical coordinates. So this x square plus y square plus z square will become r square. So it's under root of r square. That is e to the power r. And then dx dy dz will become r square times r square sine theta dr d theta d phi. Now we'll just integrate this in the first octant. Therefore, the values of r, theta, and phi are, so r will vary from 0 to 1 because we are integrating over a sphere of radius 1, and theta and phi both will vary from 0 to pi by 2. Okay. So how do we integrate this? Again, because limits are constant, just we can write this integral as products of three integral. The square e to power dr. So this is the first integral from 0 to 1. Second integral will be the sine theta d theta from 0 to pi by 2. Third integral is just d phi, so there's nothing. We are integrating a constant function, so 0 to pi by 2. Okay, so let's find this integral one by one. Again, note that this is a constant. We are integrating here a constant function, so the value of this integral is just pi by 2. Let's first find this easier integral, second one. So 0 to pi by 2 sine theta d theta. Okay, so again, integral of sine theta is cos theta, and the limits are from 0 to pi by 2. Cos by pi by 2 is 0. Okay, so this integral will just become 1. Okay, so value of this integral is 1, and value of this integral is pi by 2, and now we just find the value of the first integral. For this integral, we'll use integration by parts. So integral of r square e to the power r dr from 0 to 1. Okay, so treat r square as your first function. So this is r square e to the power r from 0 to 1 minus differentiate r square, you'll get 2r e to the power r 0 to 1, right? Because integral of e to the power r is itself. Okay, so here we'll have 1 minus twice of this integral 0 to 1 r times e to the power r dr. Now we'll again apply integration by parts. This is 1 minus 2 times r e to the power r from 0 to 1 minus integral of e to the power r from 0 to 1. Okay, and that will just become e to the power r. Okay, so 1 minus twice of e
Please use the direct formula. E to the power of r square minus 2r minus plus 2. That integral.
Okay, so I'm just
E power r.
doing
E
this
power.
integral.
Without using by parts, we can find direct integration. E to the power of r square minus 2r plus 2. Total integration.
Okay, so I don't remember all these formulas, so I'm doing this
It
again
is
and
it is
again.
just in the direct formula.
So whatever I have written, is this correct, right?
Applying first to limits 0 to 1, it is 1 square into e to the power of 1, not only 1, e minus 1. That is first
Yes.
part. If applying 1 square into e power 1, that is
Yes.
upper limit e
Yes.
minus
Yes.
lower limit 1.
Yes. So this first one is incorrect, right? If you put 1, you will get e, and then if you put 0, then you'll have 0.
It is okay.
Okay, so just calculate this second part. So again, this will become e and minus this 0, and when you put,
Right.
yeah, so
E
it's e plus 1, right?
ah,
So at the end, it will come out to be e minus 2. Okay, so our value of the integral, let's call it something. Let's say this integral is some number, but let's denote it by I. So I is equal to 8 times 1 into pi by 2 into e minus 2. So these are all values. So we'll have 4 pi e minus 2, right? That means
Ah,
first option is correct. Okay, so let's move to the next problem. That is again a similar kind of problem. So all these problems are similar, I think. So 1 minus x square plus y square plus z square in the root dx, dy, and dz. Okay, so again, the volume is a sphere of radius 1. So let's change it to 8 times 1 minus r square sine theta dr d theta d phi. R varies from 0 to 1, theta varies from 0 to pi by 2, and phi also varies from 0 to pi by 2. Okay, again, we write this integral as product of three integral. Okay, so this integral will be equal to pi by 2, and this integral we have already calculated is equal to 1, right? Because minus cos phi and 0 to pi by 2. So we have to just find this first integral. 0 to 1 r square 1 minus r square in the root dr. So let's put 1 minus r square equal to something. Let's write s. Then this will become minus 2r dr will become ds. Right? So instead of dr, we can write ds divided by minus twice of r. And this will just give r equal to 1 minus s under root. So this will become ds divided by minus 2 1 minus s under root. Okay. And again, note that when r becomes 0, s will become 1, and if r become 1, then s will be 0. This minus sign we will use to change the limits of the integral, because when you change the variable, the integral will become from 1 to 0. So taking half outside from 0 to 1, and this r square will become 1 minus s. So 1 minus s under root s dr is ds divided by 1 minus s. So this will also become under root. Okay, so this integral is half from 0 to 1 s minus s square under root ds. Okay, so this s minus s square, will just write it in some standard form by computing the square. So this will become 1 by 4 minus s minus half whole square ds, right? So half minus
please
s
change the
square.
substitution. Hello, sir.
Yes, yes.
It is very difficult calculation. Please change the substitution. Put r equal to sine theta. Then root of 1
Okay,
minus r square is cos theta dt. Cos theta.
okay,
Uh, I think it is easy way.
okay. So this will also give you your answer. Okay. Yes,
Uh,
this will
okay.
be a little bit difficult, but you'll get your answer by this way also.
Okay. I can do.
So I have calculated it. So you'll have your answer something like y by 2 or okay, let's apply another substitution because now you can see that you can just apply this in standard integral. So what are those standard integral? That a square minus r square under root dr, and that is just equal to a square minus r square under root. So this is r times a square minus r square under root plus a square by 2 r divided by a square minus r square. Is this correct? There's some tan inverse also. So inverse of tan. Okay, so we can apply. Is this correct?
Uh, no. Sine inverse of r by a. R by 2 into root of a square minus r square plus a square by 2 into sine inverse of r by a.
Oh, it is tan inverse. Okay.
First term is okay. Second term is r by a. It is sufficient. R by root of a square minus r square is not needed.
Okay, that is for a square plus r square, I think. Okay, r by a. Okay, so in our case, this will become half s minus half divided by 2 and into s minus s square plus 1 by 4 sine inverse of s minus half divided by half. So that is you have to multiply by 2 and take this limit from 0 to 1.
Limits not 0 to 1, 1 to 0. Because if r equal to 1, s equal to 0, r equal to 1, s equal.
Okay,
Please verify limits.
but there was this minus sign also, right? So you have s equal to 0. So this integral will become from 1 to 0, but when you put dr equal to this factor, this particular factor, it has a
Okay.
minus sign also, right?
Okay.
So that will just change the limit of integral.
Okay.
So half, put 1 is 1 by 4. Okay, in the first part, if you put 1 or 0, it doesn't matter, it will give you 0, right? So the second part is that matters. So 1 by 4, if you put 0 there, you will have sine inverse of minus 1. Okay, so what is sine inverse of minus 1? So sine inverse 1 is pi by 2. So sine inverse of 2 is minus pi by 2. No, so it's plus pi by 2 in the first case, and in the second case minus pi by 2, right? If you put 0, then it is sine inverse of minus 1. So 1, so this will become plus. Okay, Okay, so pi by 8 plus pi by 8, that is pi by 4, again pi by 8. So what is our integral? I. So I is equal to 8 times, we have 1, we have pi by 2, we have pi by 8. It is coming as pi square by 2. The answer is pi square by 4. So somewhere there is a half missing.
Half missing at second term. Sine inverse coefficient is 1 by
Oh,
1
yes,
by
yes.
8, a square by 2,
It's a square
1
by
by
2,
4 by 2. That means 1 by 8.
1 by 8. So this is become 1 by 8. Right, you are correct. Thank you for that. That means this will become pi over 16, right? We have pi by 4. Okay, so I think I have finished all the problems based on these triple integrals, and so I can do other problems, right? But we
Yes,
have some
I
time.
can do. Okay, thank you.
Okay, you're welcome. Okay, so now we are doing the second problem. We have to find this integral. Again, we will change this integral into polar form. Okay, so first calculate, first always find the region of integral. Okay, so if you see the region of integral, you can see that the y varies from this 2x minus x square under root and 0. So let's draw the graph of y equal to 2x minus x square. Okay, it is y square plus x square equal to 2x. So this will turn out to be a circle at 1 comma 0. This is a circle based at 1 comma 0. So this is our point 2 comma 0. And we have to integrate because this x varies from 0 to 2, right? So we have to, the region of integral is the first half of the circle, the upper half, that is the semicircular part. And if you change this integral, now let's put theta equal to constant, and then we can see that r varies from 0 to, okay, let's find this equation of the circle into polar coordinates. Okay, so for polar coordinates we put x equal to r cos theta and y equal to r sine theta, and our circle has equation x square plus y square equal to 2x. That means r square equal to 2r cos theta. That will give r is 2 cos theta. Okay, that means r varies from 0 to 2 times cos theta, and then theta will vary from 0 to pi by 4. Okay, so this given integral x square plus y square dy dx 0 to x minus x square is 2x minus x square from 0 to 2. If you change it to the polar coordinate, then this will become r varies from 0 to 2 cos theta, and then theta will vary from 0 to by 2. Then x square plus y square becomes r square, and dy dx will be replaced by r dr d theta. This is r cube dr d theta. Okay, so let's first integrate r cube, because here we cannot write it as a product of two integral because the limits also depends on variables or parameters theta. So we'll just integrate the first integral is r to the power 4 by 4, and we'll just put limits from 0 to 2 cos theta, and we'll integrate whatever comes out from 0 to pi by 2 with respect to theta. Okay, so 2 to the power 4, which is 16 by 4, that means 4 cos to the power 4 theta d theta 0 to pi by 2. Okay, so let's write cos. Let's what is cos square theta? This is 1 plus cos 2 theta divided by 2, right?
I think it is not necessary to integrate. It is cos
Okay,
to the power of 4 theta. That means 4 in 3 by 4 into 1 by 2 into pi by 2. Simple answer.
okay, so there are
4
some
is coefficient.
formulas.
4 is already coefficient.
Okay,
4 into 3 by 4, 1 by 2, pi by 2.
4 into 3
4
by 4
into 3
into
by
1
4, 1 by 2 into pi by 2.
pi by 2. Okay, so 4 will cancel, so it's 3 by 3 pi by 4.
3 pi by 4.
Yes. So what formulas are these? I don't either I don't know
It is
about them, or I don't remember.
sine to the integral 0 to pi by 2 sine to the power of n theta d theta formula. N minus 1
Okay,
by n into n minus 3 by n minus 2 into, and so on. If last product is 1 by 2 into pi by 2, if last product is 2 by 3 into 1, it is a reduction formula.
okay. Yeah, otherwise I was calculating it by putting all these double angles cosine formulas, and then changing it to cos 2 theta, and then taking again square again,
Okay, okay,
making
okay.
it cos 4
It is
theta.
a lengthy process. Actually, I have 32 years experience in teaching in mathematics,
Okay.
particularly in MSET. So I can do directly this type of problems.
Yeah, so these formulas, they will help in this competitive exams.
Yes, yes.
They will save you some time, a lot of time. Okay, then let's start with the third problem. Again, the region of integration is, you can see this, it is the disk of radius 1. So this is our region of integration. We'll just change the integral into polar coordinates, right? What is your integral? This sine of pi. So if we change it, this will become 4 from 0 to 1, 0 to pi by 2, because we'll just integrate in the first quadrant. So it's 4 times of this integral in the first quadrant, where limits of r from 0 to 1 and limits of theta from 0 to pi by 2. Instead of dx dy, we'll write r times dr d theta. So this is sine pi r square. Yes. Okay, so in this case, these limits are just constant functions. So you can write them as a product of two integrals. So theta, if you integrate, you'll just get 2 pi from 0 to 1 sine pi r square. Let's again substitute pi r square equal to t. we'll have 2r 2 pi r dr equal to dt. Okay, so this is our 2 pi, this is r, so we'll just put 2 pi r dr equal to dt, and this will come 0 to 1 of sine t dt. Is this correct? Okay, so I have to change the in limits of integration also. I forgot that this is not just 0 to 1. Okay, so let's find out the limits of integration when r will become 0 and t will also become 0. If r becomes 1, then t will become pi. So limits are from 0 to pi. So what is cos pi? Is minus 1. So plus 1, that is, so it will become plus. Okay, so the answer is 2. So option B is correct. Let's move to the next problem. Okay, so we have to find the integral for the region R, where R is the region bounded by two parabolas. So what are these parabolas? Let's make the region of integration. So first one is y square equal to 4x. So y square equal to 4x will be something like this, right?
Uh,
And so this is y square equal to 4x, and we'll have x square equal to 4y. Okay, so this is a point of intersection, and we note that this point of intersection is 4 comma 4, and this is another point of intersection, which is origin, and we are integrating inside this region. Okay, we have to find the limits of integration. We are integrating over the region R, y, dx, dy. Okay, so we can integrate this integral into any order. So let's integrate in the given order. So first integrate with respect to y, and then we'll integrate with respect to, so first integrate with respect to x, then we'll integrate with respect to y. While integrating with respect to x, you have to keep y to be fixed. So if this is an axis of y equal to constant, then you can see that x varies from the first curve to second curve. So this is the range of x. So x varies from first curve to second curve. Okay, so this is our first curve. In this first curve, what are limits of x? So x varies from y square by 4. So lower limit is y square by 4. What are our upper limits? It's twice of root y. And then y varies from 0 to 4. Okay, so we are integrating first with respect to x, so y will come outside, and we have 2 root y minus y square by 4 dx. So this is our integral. So twice of y to the power 3 by 2 minus y cube by 4. We have to integrate this function with respect to y, not x. So this is typo. Okay, so what is the integral of y to the power 3 by 2? Is y to the power 5 by 2, and we have to divide by 5 by 2. So this is 5 by 2 and minus y to the power 4 divided by 16. Taking limits from 0 to 4. Is 4 by 5 Okay, so it is 2 to the power 5 by 5 minus 4 to the power 4. So we will have 4 square. So 2 to the power 5 is 32. So it is 32 into 4 is 128 divided by 25 minus 60. Okay, so I have taken 5 already outside, so this is just 4 by 5. So 128 minus 80 divided by 5. What is the answer? It's 20 plus 28, which is 48 by 5. Yes, so here answer D is correct. Okay, which question should I solve now? Because all these problems are similar. So there is only one problem which is a little bit different. It says that find the surface area of this conical surface that lies in the cylinder x square plus y square equal to 4. So let's do this problem. So this is a cone. What is this cone? Says this is this. Okay, so this is our cone. Okay, so this is cone which is z equal to x square by 2 plus y square by 2. Okay, and there is a cylinder also which is x square plus y square equal to 4. Okay, so this cylinder cuts this cone at somewhere, let's say this is here, and when after some time the cone will just the surface of the cone will go outside of the cylinder. So we have to find the that part area of that portion of the cone which lies inside the cylinder. So we have to find this all these areas. Okay, so we'll just find the area of the first part of the cone which is above the x-axis, and then we'll multiply by 2. Okay, so what is the where we are where does this cone intersects the cylinder? Okay, so note that this is the plane which is z is equal to 4, or it is z equal to 2. So it cuts the cylinder at z equal to 2, right? Because x square plus y square is 4. So 4 by 2 is 2. Okay, so to find area of a some surface, you have to find the area, then you have to integrate. Let's say we have to find area of some region A. So then let's denote that area by this integral, and for that we find this double integral, which is 1 plus del z by del x whole square plus del z by del y whole square under root dx dy over the projected region of A into xy plane. So this, let's say R. So R is the region in the xy plane, which is the projection of this area A. Okay. So here, what is R in our case? If we project this cylinder into xy plane, this will just circle, or the disk part of the disk x square plus y square is less than equal to 4, right? Okay, so let's find derivative of z with respect to x. Note that z is equal to x square by 2 plus y square by 2. So it will just become x square plus y square under root into r dr d theta. We have changed this into polar coordinates, and now multiply by 8 because we just integrated into the first quadrant. Okay, because we are integrating only in the first quadrant, that means the limits of r is from 0 to 2 and limits of theta from 0 to pi by 2. So you have to multiply by 4, but note that we have to find the area of that cone which is above the z equal to 0 plane and below the z equal to 0 plane. So that means you have to multiply by 2 also. So it's multiply by 8 overall. Now because we have changed it into polar coordinates, so instead of x square plus r square, let's write r square. Okay, so this is our integral. This is 4 pi because we can take, because the limits are constant, so this is a product of two integrals. So integrating with respect to theta will give you pi by 2. So this will become 4 pi from 0 to 2 r times 1 plus r square dr. Okay. Let's put 1 plus r square as t. Substituting 1 plus r square equal to t, that means 2r dr is equal to dt. That means r dr must be dt by 2. So this is equal to 4 pi under root 2 dt. Okay, so if r is 0, then t will becomes 1. When r is equal to 2, t will become 5. Right? So our area is equal to 2 pi times integral of root t. So what is the integral of root t? So it's t to the power half. So t to the power 3 by 2 divided by 3 by 2, taking limit from 1 to 5. Okay. So 2 pi. Okay, so let's take 3 by 2 outside. So this will become 4 pi by 3 pi to the power 3 by 2 minus 1. Okay, so there is again a mistake by factor of 2. Where is that? Because the correct answer is A, and that is 2 pi by 3 into 5 to the power 3 by 2 minus 1, and we are getting 4 pi by 3. Okay, I don't know where is mistake. I think there is no mistake. This is the something with the problem also. It is not mentioned if we have to find the area only area of this surface only which is above z equal to 0 plane, or we have to find the area which is the part of the surface which is below the z equal to 0 plane. So that is not clear from here. Maybe it is only the first half of the cone. In that case, we have to multiply by 4 only.
It is for only after part.
Yes.
Okay.
Okay, that means this is the correct answer. So, okay, now our time is also over. So we'll just end our live session here. Thank you everyone for joining this session,
Thank you.
and we will meet next week with the next set of problems based on the lecture material of that week.